Which ones are those? 4 and 2. We got 4. Yep. Okay. So we'll start with 2. So in number 2, it wants you to do 2 things. You're gonna end up writing the slope-intercept form regardless, but you're gonna write the slope-intercept form using the slope-intercept form and then using the point slope. So I'll rewrite what both of those are. So if we were using the slope-intercept form, if you were doing the writing linear equations part 2 and looked at the examples, it may have shown you this. Do not do this on the quiz and test, but you can do this during practice. Put this in for x, this in for y, this in for m. And we're going to solve for b by multiplying the 1/2 and the -4. And then adding 2 on both sides. And then you would rewrite that in your y equals mx plus b with your slope and your y is up. So for both part A and part B, you should get the same answer, but the work is going to be different. Yes. Don't do this. Don't use this method. Okay. You should be using your point slope on the quiz and test by putting in this for x1, this for y1, so y minus 3 equals 1/2 times x minus a -4 or plus. Tyler, go ahead and close that. And then you can distribute. And get rid of the 3 by adding it to the other side. Questions on that? For number 4, we are writing the equation of a vertical line, so we need to know what type of line it is. Vertical line is going to be at x equals, and then we look at the x value. So you have to know those in order to get that right. Questions on that? So we're going to start our notes on parallel and perpendicular lines. Make sure that is in front of you. So who has heard those words before? Parallel and perpendicular. Good. We should have. What do we know about parallel lines? Sorry. Okay. They don't touch. They don't intersect. 2 lines that don't intersect. Algebraically, parallel lines are 2 lines that have the same slope. What do we know about perpendicular lines? They do cross. More specifically, they cross and make like a T at like a 90-degree angle. So like your x and y axes are perpendicular lines. So 2 lines that intersect at a 90-degree angle. algebraically, we know two lines are perpendicular if they have negative reciprocal slopes. I wrote what that means here in a second. So if we use that word reciprocal before taking the fraction, flipping it, a negative reciprocal is a fraction that is flipped and the signs are switched. One is negative, one is positive, or they're opposite. So a flipped fraction where the signs are switched. Or opposite. So we're going to do some examples of some negative reciprocals. So if I have 3/4 and I took that and flipped it and made it negative, what would that be? Negative 4/3. What about 2? I heard negative, but not the rest. 1/2, yes. Because that's really over 1. What about negative 7/8? Positive 8/7. What about 1? Negative 1. Now this last one is a tricky one that we have to remember. So if I have 0/1 and I take it and I flip it, what is negative 1/0? Someone said it, undefined. So we have to remember that 0 and undefined are negative reciprocals, which means they're perpendicular. Okay, so parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. So we're going to find the slopes of these given problems and determine are they parallel, perpendicular, or neither. So to find our slope, we're going to use our slope formula, y2 minus y1 over x2 minus x1. And we're going to start finding that for a b of number 1. Label them if you need to. So that would be 6 minus 3 over 2 minus a negative 2. What would that slope be? 3/4. Then we're going to do the same thing for CD. Find the slope of that. What would that slope be? Also 3/4. So these two lines are parallel, perpendicular, or neither. If they're the same, they're parallel. So you can write out the word parallel, or you can use the symbol that you'll see in geometry to vertical lines. Questions on how we found that before we move on? Okay. Let's try number 2. Do the same thing. Find the slope for AB. What is that slope? 2/5. And then do the same thing for CD. If you did 2 minus 4, then you'd have to do 0 minus 5. but it doesn't. What is that slope? -5/2. Are these parallel, perpendicular, or neither? Perpendicular. How do we know that? They're flipped and the signs are opposites or negative reciprocals. So you can write out perpendicular or use this upside down T. Right. Then I'm going to show you some neither cases. In number 3. So let's find the slope of AB once more. What is the slope of AB? -2/3. And find the slope of CD. Are these parallel, perpendicular, or neither? Neither, because they're not related at all. They're not the same. They're not negative reciprocals. So that's an obvious neither case. Some other ones are not as obvious. You might have numbers that aren't related at all. You might have the same numbers, but maybe one is positive, one is negative. So -3/4 and +3/4. That would also be neither. And then you might have reciprocals, but not negative reciprocals. So let's say 2/5 and 5/2, or -2/5 and -5/2. That would also be a neither case. Questions on any of those? Okay, we're going to move on to the next one. We're going to do number 5. I will rewrite the slope formula once more. What is the slope of AB? It will be undefined. So I'm going to write it as is first, but keep in mind it is undefined. And then do the same thing for CD. What is that slope? It would simplify to 0. I'm going to put it as 0/3 for right now. So that one's actually 0. Okay, so if you didn't keep going, if you didn't simplify it to undefined and 0, and you saw this, you might think it's neither. But you need to keep going and remember that this one is 0, and this one is undefined. And then those would be parallel, perpendicular, or neither. Perpendicular. 0 and undefined will always be perpendicular. They don't look like it, but they are negative reciprocals. Questions on that one? Okay, we're going to move on to some equations now. Starting with number 9. Looking at the slopes, are these two equations parallel, perpendicular, or neither? Or parallel. How do we know that? Because they're the same. What about number 10? Say that louder. Perpendicular. How do we know that? They're negative reciprocals. They're flipped, and one is positive, one is negative. Yes. What about 11? Not parallel. They're neither. Because they look the same, but one is positive, one is negative. So that's a neither case. Okay, then we're going to do 12. If we had something like 12, we have to solve both of these before we could continue and determine if they're parallel or perpendicular or neither. How would I solve the one on the left to get y by itself? We will divide by 6, but not first. Subtract x. Rearrange this so that we have negative x plus 30. Then we could divide by 6. Oh, I just moved this entire thing. So we have y equals negative 1/6x plus 5. And then how would we solve the one on the right? How would we get y by itself then? What do you say? Divide by 3. So y equals 6x minus 2. Are those parallel, perpendicular, or neither? Perpendicular. Because this is 6 over 1, so those are negative reciprocals. Do you have any questions about that one? Okay. I want you to try number 14. Are these parallel, perpendicular, or neither? Parallel. Because they have the same slope. I didn't say this earlier, but parallel lines also have to have a different y-intercept. Otherwise, they would be the same line. Okay, we're going to do one more of these and then move on. Number 16. This is y equals and an x equals, so we have to remember what type of slopes each has. So if this is a y equals, what type of slope does that have? It is a horizontal line. What type of slope does it have? 0. What about an x equals? It's undefined. So 0 and undefined are parallel, perpendicular, or neither? Perpendicular. Now I'm going to draw a visual of this so you see what it looks like. You can do this if you want, you don't have to. So because I have that vertical line and that horizontal line, those are always going to be perpendicular. They're always going to cross and make that T, that 90-degree angle. But if I had 2y equal just a number, those would be parallel because they have the same slope. Or 2x equals, those would be parallel because they have the same slope. If I had one of these and like a regular slope intercept, those would be there. Questions about that? Okay. Everyone take 15 seconds and stand up and stretch. Shake out your hands. We're going to do 4 more problems, then you guys are going to practice. If you want. So the next page that says parallel, perpendicular, or neither, that's strictly for you to practice whenever you want. So go on to this page. So part of the parallel and perpendicular lines is being able to determine is it parallel, perpendicular, or neither from equation, from slope, from a graph, which you'll do in Delta Math. And then the other part is being able to write an equation that's parallel or perpendicular. So we have to keep in mind that parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. And what's going to happen is we're going to be given some equation and a point. And we have to write an equation that is parallel or perpendicular to that equation that goes through that point. Similar to when we were writing equations from slope and a point, it's going to be kind of the same. We're going to use our point slope formula again. So the very first thing we need to do is cross out the y-intercept because we're not going to use it. We don't need it. It will only confuse you later. So just get rid of it. Then, because this is parallel, we know the slopes have to be the same. So we're going to use that same slope. Guys, stop talking. We're going to use that same slope, m equals -4. I'm just rewriting it so that I remember that's the slope I'm using. And then I'm given my slope, I'm given my point, so those are what I'm going to put into my equation. So y minus 7 equals -4 times x minus a -2, or change that to a plus. Then we can distribute the -4. And add 7 on both sides. When we do that, what would that final equation be? Y equals -4x minus 1. So if I'm looking at that and I'm comparing it to the original, these are parallel, they have the same slope and different y-intercepts. Do we have any questions about that? The next one is similar, but also different, because this is in slope in standard form. So I have to solve that first. And do that over here. So I have to get y by itself first by doing what? Subtracting x. There we go. So we have -3y equals -x plus 9. And divide everything by -3. So we get positive 1/3 x minus 3. Now that does not answer our question. We just rewrote the original in slope-intercept form. So now we have to go back and do this process. So cross out that y-intercept. We don't need it. We have our slope. It's parallel, so I'm just going to write that over here so I know what it is. And I have my point x1, y1. So we're going to put that back into our equation. Minus a -1 or plus 1 equals 1/3 times x minus 3. And from there, start to solve. you distribute and you subtract 1 on both sides, what is that final equation? Funny, I didn't see your hand. My apologies.
Y equals 3x minus 3.
Yes. So again, this is parallel to the original. It has the same slope and it goes through a different y-intercept. Any questions so far before we get into the perpendicular ones? The process is basically the same, but we have to do one additional thing first. So in number 3, we can still get rid of that y-intercept, we don't need it. But because this is perpendicular, I have to change the slope, make this a negative reciprocal. What would that new slope be? Negative 1/2. You have to do that first. If you continue with the wrong slope, your work and answer would be wrong. So now we can do our point slope with this slope and this one. Y minus 3 equals negative 1/2 times x minus 4. And go ahead and start solving that. And that final equation is negative 1/2 x plus y. Any questions on that one before we do this last one? So similar to number 2, this one is in standard form, so we have to solve that first and then proceed with everything else. I'm going to do that off to the side. What's our first step? Yes. So we have 3y equals negative 5x minus 21. Divide everything by 3. So we have y equals negative 5 over 3x minus 7. Then we need to change our slope to the negative reciprocal. What would that be? Positive 3 over 5. So in this case, we really don't need any of this. I can cross the whole thing out, but I'm going to use it later to show you how you could check your self-assessments. I'm not going to use any part of this. Now I have my new slope, I have my point, and now we're going to use our point slope. Go ahead and start that, put that into your equation, and solve that. final answer should be y equals 3/5 x plus 4. Do you have any questions on that? While you're practicing, you could be using the method I'm about to show you in Desmos to check yourself, but still know how to do this algebraically as well. I'll have Desmos open though. So I'm going to use that last example as our example. So the first thing I'm going to do is put in the original equation, the 5x plus 3y equals -21. And then, because we solved that, I'm going to put in the equation that we got to make sure that they overlap, which was y equals -5/3 x minus 7. So that happened really quickly, but they should have overlapped. So now I know that was the right equation. Then I'm going to put in my point. And I'm going to type in y equals mx plus b. And you're going to get something that looks like this. You're going to add in all the sliders. And this will work for any writing the equations, parallel and perpendicular. If you know what your slope is, so for 4, we flipped the slope and made it positive so that it was 3/5. Then I can move my b by pressing play or moving the slider until it goes through this part. Oh, because I also put too many things there. Hold on. And then I can see the equation we solved for is correct. Questions on this?
So I just have to check.
Mm-hmm. So while you're practicing, if you need me to show you this again, I can do that. You have a couple different options for the rest of the class. You can continue working in the packet. You can work on the 2 delta maths that are due today, the writing linear equations part 1 and the writing linear equations part 2. Or, multiple options. You can work on the parallel and perpendicular lines delta math, which is now in the side link. The writing's still fine in the assignments. But that one's due next week, the parallel and perpendicular. Or if you need to finish your test, you can do that. Retake work can happen if you finish all 3 delta math.